All right, so we are continuing independent and dependent events. Example 2, determining whether events are independent. A group of 4 students, including 1 boy and 3 girls. The teacher randomly selects one of the students to be the speaker and a different student to be the recorder. Use a sample space to determine whether randomly selecting a girl first and randomly selecting a girl second are independent events. Okay, so again it says use a sample space. So that means we're going to have to create a table with all the different outcomes. All right, so we have a group of 4 students, 1 boy and 3 girls. So let's say we use B for boy, and we're going to use G1 for girl 1, G2 for girl 2, and G3 for girl 3. So those are our 4 possibilities. It says the teacher randomly selects one of the students to be the speaker and a different student to be the recorder. Use a sample space to determine whether randomly selecting a girl first and randomly selecting a girl second are independent events. All right, so we'll have to use the formula again to find out what that percentage would be. But first, we got to create a sample space. So let's say we go with the boy first. So we're going to say the boy gets picked with girl 1, and the boy gets picked with girl 2, and the boy gets picked with girl 3. So that would be all the different possibilities where the boy gets picked first. All right, then let's say the girl, G1, gets picked first, and she goes with the boy. The girl 1 goes with girl 2, and girl 1 goes with girl 3. So now girl 1 has been first with all the different possibilities. All right, now let's say girl 2 gets picked with the boy, and girl 2 gets picked with girl 1, and girl 2 gets picked with girl 3. And that would be all the different possibilities of girl 2 being picked first. All right, so the last thing would be girl 3 gets picked first. So let's put her with the boy. And then girl 3 could be with girl 1, and girl 3 could be with girl 2. So this would be all the different outcomes. Didn't mean to do that. Let's see here. All right. Now that we have our different outcomes, now we can look at the different possibilities. So let's see what this question says again. The teacher randomly selects a speaker, one of the students to be a speaker and a different student to be the recorder. Use a sample space to determine whether randomly selecting a girl first, all right, a girl first, and randomly selecting a girl second are independent events. So the first thing we need to do is find the probability that a girl is first. And then we need to find the probability that a girl is second. All right, so that's the 2 probabilities we need to find independently. So a girl first, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 12 possibilities that the girl's first. 9 out of 12 can be reduced. 3 goes into both 9 and 12. 3 goes into 9 3 times. 3 goes into 12 4 times. So that will reduce to 3 over 4. All right, what is the probability that the girl is picked second? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, this is 9 over 12, or 3/4. All right, so just like we did the first time, we want to see if we multiply those, what do we get? All right, so the probability of girl first and girl second. All right, so using the formula, we're going to multiply because independent events says that you get the product. So that's going to be 9 over 16 and 9 over 16 will reduce. Will it reduce? I do not think it will reduce. So let's see, that's using the formula. So let's see if we look at the table, if we look at all the possible outcomes, let's see what happens. So let's get our highlighter again. All right, so we want to know probability of a girl first and a girl second. So a girl first and a girl second. Here's a girl first and a girl second. Girl first and a girl second. And a girl first and a girl second. So that's going to be 1, 2, 3, 4, 5, 6. Go back to my pen here. So that's going to be 6 out of 1, 2, 3, 4, 5, 6 times 2 is 12. So 6 out of 12 is 1/2. All right, so 9/16 does not equal 1/2. So that means these are not independent. So these events are not independent. Example 3, determining whether events are independent. Use conditional probabilities to determine whether the events are independent in examples 1 and example 2. All right, so remember conditional probabilities of independent events. When two events A and B are independent, the conditional probability of A and B is equal to the probability of A, and the conditional probability of B given A is equal to the probability of B. All right, so the probability of A given B is the probability of A, and the probability of B given A is probability of B. All right, so let's look at example 1. I'm going to go ahead and copy over the table that we used for example 1. All right, so here's the table that we used for question 1. Remember, we used the table to find out the correct answers for question 1 and the correct answers for question 2. For correct answers, answer 1 or question 1 would have been probability of A, and the percent correct or the probability that we're correct on question 2 would be probability of B. All right, and I'll scroll back real quickly so kind of remind you of that. So probability of A, this was correct on question 1. Probability of B, correct on question 2. All right, so conditional probability. So what do we want to do to find the conditional probability of this? So we want to determine whether the probability of B given A equals the probability of B. So let's say the probability, let's say we want to find the probability of B given A. And what we're going to do is determine whether that is equal to the probability of B. And that's just given this formula right here. If we have the probability of B given A, it should equal the probability of B. So how are we going to determine that? Well, again, the question type is correct on question 1, correct on question 2. All right, so I'm going to put the probability that probability of B, that would be correct on question 2, given correct on question 1. All right, and that's what we're looking for. All right, so we've already highlighted in the last example the ones that had 1 and 2 are both correct. Now we want to know correct for question 2 given correct on question 1. So this one has the first one correct. This one has the first one correct. This one does. And this one has the first one correct. And the ones that were highlighted, of course, have it correct. So 1, 2, 3, 4, 5, 6, 7, 8. So correct on question 2 given correct on question 1. So these are the ones that are correct on question 2. They're already highlighted. And so there's 4 out of 8. 4 out of 8 again reduces to 1/2. All right, so that gives us the probability of B given A. Now we need to know, does that equal the probability of B? So we have to find the probability of B. So what's the probability of B in this case? The probability that question 2 is correct. So the probability at question 2 is correct. So let's use a different color here. All right, so question 2 is correct here. Question 2 is correct here and here. Question 2 is correct here and here. All right, so 1, 2, 3, 4, 5, 6, 7, 8. And that's out of the total 16. So 8 over 16, that reduces to 1/2. So that is the probability of B. So probability of B given A is 1/2, and the probability of B is 1/2. So that means that these are independent. So these are independent events. All right, so we use conditional probability to determine whether events are independent for example 1. Now it asks us to do the same thing for example 2. So make sure you've got this written down, anything that you need for your notes. I'm going to erase this and we're going to look at example 2 the same way. All right, so now we're looking at example 2 again. So remember, the probability of girl first was your probability of A, and probability of girl being picked second was the probability of B. So what we want to do is look at the probability of a girl being picked second given a girl was picked first. All right, and we want to determine if that, okay, if the probability of B, which is a girl second, given girl A first, or the girl was picked first, we want to know if that's going to equal the probability of B. So that's what we're trying to determine to tell if these are independent. All right, probability of girl second given girl is first. So we've already got these picked that the girls are second. That's given from the other. And then here's a girl first, and another girl first. So that's going to be 6 out of a total of 9. 6 out of 9. And 6 out of 9 reduces to 2/3. All right, so does that equal the probability of B? Probability of B is a girl is second. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be 9 out of 12. 9 out of 12 reduces to 3/4. So those are not the same. So these are not independent.